Hi everyone, this is Dr. Chukka Santhaiah, Associate Professor of Computer Science and Engineering, Institute of Aeronautical Engineering College, Hyderabad. Today we discuss about the machine learning concept of concept learning. From that we discuss about the candidate elimination algorithm. Here candidate elimination algorithm is one type of the machine learning algorithm. It is a part of concept learning. And it is a candidate elimination means we are fixed some algorithm or we are fixed some hypothesis. That hypothesis not justify the condition, that is about the not consistent. Then we can simply eliminate that algorithm from the hypothesis. Means we take some set of hypothesis, that is about the h of x, means about the subset of, means here set of hypothesis is nothing but a h, whereas h is nothing but a subset, means it is a subset of the hypothesis, main hypothesis. So if any hypothesis condition, if any hypothesis constant or consistent, it must be justified that condition, that is about the h of x is equal to c of x. Whereas h of x is nothing but a given hypothesis. Means here h of x is equal to given hypothesis. As well as c of x is nothing but a training example or the concept example. Concept or target concept. Means target function or target concept. Simply we can say the c of x is nothing but a training and resultant about the training examples. That is about the c of x. Means we can give them an hypothesis that is about there are some, for example, s is a hypothesis, it has some attribute values. Either sunny or warm or normal or cool. Here normal, cool, cool as well as strong and same. Means some attributes are there. From this we have defined this about the some hypothesis. Given hypothesis are training example about the hypothesis analysis. It is about the CF. Means it is output is enjoy the water sport, that is about yes or no. It is called c of x. Whenever you can this hypothesis that is about the h of x, means it is also some attributes values up to some depends on the number of attributes are there. We are compared with the training example with the given hypothesis. It is constant with the both algorithms, both hypotheses. That is about the h of x is equal to c of x. Then only it is called consistent hypothesis. Means whenever we can take some given hypothesis that is about h of x, then we can compare that given hypothesis to the target concept or the target function, that is about the c of x. That is in the training, means about the our example. And what is the need of the candidate algorithm in this concept learning? Means what is the need of the candidate elimination algorithm in machine learning? The main reason about the main need of the concept learning, means concept elimination algorithm is, whereas we discuss about the find S algorithm, like in a find S algorithm, this find S algorithm is only focused on or consider only positive training examples. Means it is discussed about only positive training examples. There is not, means it is only considered the positive training examples. Whereas come to run, if any negative training example is, we can simply ignore that training example. Ignore that training example. Means sometimes, as we go to some hypothesis analysis, positive hypothesis also plays some role, as well as negative hypothesis also plays some role. So To overcome that disadvantage about the findings algorithm, that is about the finding the findings algorithm only focused on the positive examples. We need some analysis on the negative training examples also. So, to overcome that disadvantage, we are moved to the next algorithm. That is about the candidate elimination algorithm. What are the properties about the candidate machine learning algorithm, candidate elimination algorithm? The first condition or the first principle about the candidate elimination algorithm is, first it is considered. It considered both positive hypothesis as well as negative hypothesis. Means the first properties about the candidate elimination algorithm is, it is discussed, it is considered both algorithms, means about the positive training example algorithms hypothesis as well as negative training hypothesis. Next, in between positive as well as negative algorithms, one specific concept is there in candidate elimination algorithm, that is called version space. Means the version space. This version space is nothing but it has some set of hypotheses from this, some hypothesis that is about the H1, H2, H3 as well as H4, and some version space. Means some it is stored some same algorithms in the version space. That is about the H1, H2, H3 as well as H4. We can store that. Means when you discuss about the candidate elimination algorithm, what is where it is how placed in version space in the candidate algorithm. That is about the, it is means it is a intermediate or maybe it is a place in between the specific hypothesis as well as general hypothesis. Means the version space is there in the candidate algorithm is located in specific algorithms, means about the, for example, S0, it is specific. The specific algorithm is indicated represented by the null value, that is about the pi, as well as pi as well as null. Means based on the our attributes, we can take only 4 attribute values. And then we are differentiated by the general hypothesis, that is about the question mark, means 4 question marks. Why? Because only inputs 4 attributes are there. So in between this, we are generating the one more hypothesis, means about the one more attribute values. It is called version space. Means whenever we discuss about the candidate elimination algorithm, there is a part is there, the version space part. Importance is there in version space. That is about the version space. Means if version space, what is the need of the version space here itself? If any negative examples are there, negative training examples are there, we try to generalize that. You can try to, you compare some generalized functions with that about the specific to the general. So whereas come to the specific, especially specific hypothesis represented by the null value as well as general hypothesis represented by the question mark. And we have some conditions about the same conditions, like summation about the comparison of 2 same attribute values, it comes same attribute. Means like, for example, Sunny is there, we are compared with the 2 attribute of Sunny in one example, that is the first example. And second example is, so we are compared with the Sunny. Means the out result is same output, same parameter, that is about the Sunny. Whereas come to the second one, means about it is nothing but a second, for example, here Sunny is there in the first example. In second example is Rainy is there. Here comes under the generalization, means generalized. And then anything with compare with null value, that is about the Sunny, it contains the some attribute value, that is about the Sunny. And if anything is compared with the generalization, that is about the, it is comes from the generalization. This is the principles, basic conditions are there when we are compared with the given hypothesis plus training example hypothesis. So keeping this, these are conditions when you discuss about the any algorithm in concept learning. That is about the find this algorithm or maybe concept learning algorithm. And then version spaces also play a major role in elimination algorithm. That is especially it is tested the condition. That is about the h of x is equal to c of x. This is one condition. Means if hypothesis consistent. It is represented. It is hypothesis consistent. And in some cases, x of x is not equal to the c of x. It is inconsistent. Means not stable, not consistent. This also play a major role in candidate elimination algorithm. These two concepts comes under the workspace concept. So then we can go to the next about the main concept. That is about the candidate elimination algorithm. The candidate elimination algorithm computes the version space containing all hypotheses from the H that are consistent with the observed sequence training examples. Means this candidate algorithm is especially contains the version space. It's about the version space means it is a version space. It is a version space. It contains all hypotheses means all hypotheses means H1, that is about the H1, H2, H3 as well as H4 that are consistent with observed sequence training examples. About the training examples is dependent by the capital D means it is dependent by the some attribute values training example X1 comma X2 as well as X3. And then candidate elimination algorithm is it begins by the initializing the version space with the set of all hypotheses H means about the set of hypotheses means here H is nothing but it contains set of hypotheses means it is H1 comma H2 H3 H4. It is analyzed means it is begins by the version means it contains all hypotheses. It begins by the generalization means initialization is a version space set of all hypotheses H. That is by initializing G boundary means about general boundary set to the contains the most general hypothesis in H. Means we can compare with, we can decide, we can assign the some general hypothesis. That is about the G naught. Means about it is a G naught. Means whereas G naught is equal to, it implies generalization. Basically it is represented these question marks. As well as it is introduced by the system is S means specific boundary and contains the most specific hypothesis means most specific hypothesis. It is defined by the null value, that is pi. When you count this hypothesis, whereas come to the G naught as well as S means generalized hypothesis as well as specific hypothesis. These examples, these attributes are this number is depends on the number of attributes are there in training examples means number of attribute are there in training examples means training examples. It is reference. In case in training examples 4 attributes are there means we are referring to only 4 values. Whereas it is a specific one. And then we can take generalized one means about it here also only specific mention the only 4 attribute values. 4 question mark. That is means based on training examples it has some specific representations. That attribute is depends on the number of attributes are there in training examples. We can discuss about, we can mention about showing represent about the general hypothesis as well as specific hypothesis. Right. These two boundary set delimit the entire hypothesis space because every other hypothesis in H is both more generalized than the generalized to the and more specific. Means we are mainly focused on if any algorithms are there, give some conditions in between the two hypotheses. Means more specific as well as more generalized hypothesis. As each training example is considered, that means G and S means specific and generalized boundary. General boundary sets are generalized and specialized respectively. To eliminate from the version space any hypothesis found in connection with the new training examples. Means in this either may be specific or maybe generalized. We are checking the condition. That is about the that hypothesis is consistent or not consistent with the training examples. Means if an H1 hypothesis is there as well as H2 hypothesis is there as well as H3 and H4 hypothesis is there. Means 4 hypotheses are there. For example, H1 is stable with, means it is constant with the, means H of X1 is equal to C of X1. It is constant. We can keep as it is. In case H of X2 is not constant, not equal to the C of X2, means it is simply eliminated that hyper from that large version space. That is it. Means as each training example is considered, that is about general and specific. Means specific and general boundary. Respectively, to eliminate from the version space any hypothesis found inconsistent with the new training example. Means if any hypothesis not consistent with the new training examples, we can simply eliminate that hypothesis. Means I can give some clarification about this with some little bit example. You can check it once again. Right. After all examples have been processed, the computed version space contains all hypotheses consistent with these examples and only these hypotheses. Means after eliminate the inconsistent hypothesis, that version space is contains only consistent hypothesis only. For example, take some more example. Means it's about the hypothesis inconsistent with the new training examples. The given hypothesis, this one is H1 for example. We are compared with the sunny, warm, as well as normal and safe. For example, we can compare it. That is hypothesis. Means given hypothesis. We are trying training examples. That is about the here is sunny, comma, warm, comma, question mark, comma, sun. Means we can check it. This H1 is about C of X, for example. C of X. This one is H1, C1, for example. Means it is about the training example 1. That is about the training example here. Means it contains the sunny, warm, question mark, and same. So it is about C of X is equal to Y. Means about the yes. In case that resulted output is yes. We are compared with one given hypothesis. Means about the it is given hypothesis. We are compared the training examples. Whereas come to the S, same parameter S is equal to S, and warm into warm means about the warm with warm. If anything is question mark, means it is about the negotiable, means anything is accepted, not issue. And then we go to the S is equal to yes. Means here nearly 3 attributes are satisfied the condition. Why? Because here is any value is accepted. Why? Because question mark is generalized. So output is also yes. So it is C of H of X is equal to, means about the H of X is equal to C of X. It is constant. If the condition is not satisfied, we can simply eliminate that from the hypothesis. Means like that we are store the all hypotheses in the version space. Then we can compare with the training examples one by one. If any hypothesis is there, if any hypothesis is not consistent, it means it inconsistent, we can simply remove that hypothesis from the version space. We can take some example. Here H1, H2, H3, H4 is there. It's about the version space, means version space, for example. We are make some conditions and compare with the training examples. That is about H1 with the X1, C of X1 as well as H1 is C of 2, like that. Means if any for example, hypothesis 2 is not satisfied, hypothesis 2 is inconsistent and hypothesis 3 is inconsistent. So finally, how many hypotheses are remaining in the workspace? Only H1 as well as H4 is remaining hypothesis in the workspace. Why? Because the H2 as well as H3 is not constant, means inconsistent with the training examples. So we can simply, the workspace is available only 2 hypotheses. Means actually initially 4 hypotheses are there. But whenever compare with, means we can take some analysis. Only 2 hypotheses remain same in workspace. That is thing about this. Means after all examples have been processed, The computer version space contains all the hypotheses consistent with these examples and only these hypotheses. Means after computing in all processes about the hypothesis, only workspace is contains version space is contained only consistent hypothesis only. If any inconsistent hypothesis is there, we can simply eliminate that hypothesis. Right. That is about the general condition. What is the procedure? General algorithm about the candidate elimination algorithm. First one is initialize the G, means generalize to the set of maximum general hypothesis in H. And the second one is initialize the S, means specific, means to the set of maximally specific hypothesis in H. Means first we can initialize about the general hypothesis, whereas G is equal to question mark. One second. Means the general hypothesis considered like this, means about the general hypothesis. We can take question mark, initialize first one, maximally generalized question mark as well as question mark. Why? Because three attributes is there. For example, we can. And we can go to specific, means it is also initialize the specific set of maximum specific hypothesis there about this one. Means about the yes is equal to specific means null value. According to our example, only we can take three attribute values. Like that. Means initially we can decide, we can assign, we can initialize this hypothesis with the initialized values in the workspace. Right. If D is positive example, for each training example D, do operation. Means our training example is there, D. D is nothing but some attribute values, means about the, whereas D is x comma c of x. It is a attribute, means about the training examples. Means where training example is C, means x is about attribute value. Means whereas come to the sky, it attribute value is sunny. Whereas C of x is called resultant, means target about the concept target about the training example. It is yes or no. That is meaning about C of x. Means we can perform the operation based on these training examples. Right. Means if D is positive example, means training example is positive. Means how we can analyze it is a positive or it is a negative. Means how it is, how we can define, how we can finalize it is a positive training example or a negative training example. Means we can take some example, say big example about it. Enjoy the water sport, enjoy the sports or not. Like about the various parameters. Means for example, we can take some value about the first attribute. Training example is one is there. Some attribute value is about the first day, sunny. It is about the some example. Means we take some sky. For example, sky attribute value is sunny. And we can take some humidity. It is normal. It is normal. Humidity value, it is normal. And it is wind. It is also strong. And it is forecast. Means about the same. And final reason is enjoy the sports. Means enjoy the sports or not. Means it is yes. So in the first training example, resultant value is positive. Means why? Because it is yes. So automatically it is represented by the positive training example. Based on this training example, we can analyze, we can perform some operation about the candidate elimination algorithm. Means if training example is positive, remove from the G any hypothesis inconsistent with the D. Means we can remove general hypothesis. If any inconsistent hypothesis is there, we can simply remove from the training examples. D means it's training examples. We have to do some operation with training examples about the general hypothesis. If it is inconsistent, we can simply remove that hypothesis from the general hypothesis. Next, for each hypothesis yes means specific in yes means about some hypothesis in yes that not consistent with D. Means in case some specific hypotheses are there, from the specific hypothesis also not some hypothesis means hypothesis not consistent. We are also remove from the hypothesis from the specific hypothesis. Means remove S from the specific hypothesis and add to all, means add to S specific to all minimal generalization H for the S such that H of H is constant with training example. Means we can add the all minimal generalizations H of S means such that H is constant with D means training example. And some member of G is more generalized than H. And remove from the S any hypothesis is that more general than the other hypothesis in S. We can remove that any hypothesis more than general to the specific hypothesis. We can remove that one. And second one means if D is a negative example. Here D is nothing but a training example. Training example is a negative. How we can define it is a negative training example? How we can finalize? How we can decide it is a negative example or not, or positive example? Already we discussed about the positive examples. How it is decided? It is a negative training example. Means we are going to the something. Means about the, for example, takes about the same hypothesis. That is about the sky value is there. Sky attribute as well as humidity attribute. That is about the humidity. And next one is wind hypothesis. And next one is water hypothesis. And next one is forecast, for example. Nearly 5 attributes are there. And enjoy the water sport, enjoy the sports or not. This is about the yes or no. Means, for example, we can take sky is a rainy. Means about the rainy. Here is normal. Sky values, sky attribute values rainy. Here is normal, humidity is normal, wind is strong, as well as water is cool, and forecasting is change. Is enjoy the sports means this no. Why? Because basically first parameter is rainy means there is no chance for enjoy the water sport. Enjoy the sport means automatically is no means the resultant output is no. So it is represents a negative training example. Before we can start any analysis about the hypothesis, we must checking about the given training example is a positive or negative. Means whenever it is a negative, whenever it is a negative, we are go to the one more operation. What is that operation? Right. Means if given training example is a negative, what we can do? Means remove from yes. Means remove from any hypothesis from the yes. That is, it is inconsistent with the training example. Means we can remove from that yes. Means remove the specific hypothesis that is inconsistent with the training example. Means about the D. And for each hypothesis G, that is about generalization hypothesis. And G means generalized values, means about general attribute value. And generalization is that not consistent with D. It is also not consistent. Means it is not consistent with D. So remove from that D. Means remove that G. Means again, this one is also removed from the G. Why? Because it is not consistent with the training example. We can remove that. And then we can add to the G. Means general hypothesis to all minimal specializations H and G such that H is consistent with the D. Means it is removed. I can add the all values, all remaining hypothesis which is consistent with the training examples. And some members of the S means about specific is more specific than the H. And remove from G means general hypothesis, any hypothesis that is less general than the other hypothesis in G. When you observe this algorithm, if positive example is there, means training example is positive in case. We are moved to the specific to the generalized hypothesis. Means if training example is positive, means if training example is positive, means about the training example. T stands for positive, means it is a positive. We are make some operation, we are moved to some analysis from the specific hypothesis to the general hypothesis. When you observe this algorithm, means whenever we can positive, the training example is positive, we start with the specific hypothesis and move towards the general hypothesis. Whereas come to the, if training example is negative, means if training example is negative, the training example is negative, means it has some negative symbol, negative results. So in that case, we are moved from the generalized hypothesis to the specific hypothesis. That is the reverse of the positive example about the, means it is about the generalized, means about the, whereas here specific is there as well as generalized there, means we are moved to the bottom to the top if training example is negative. In case the positive example is positive, we are moved to the top to bottom. That is thing about the, this means whenever observe this algorithm, it has some example, it has some notice there, notice point is some notice is there. Means finally the candidate algorithm training example is positive. We are start from the specialized hypothesis to the move towards the generalized hypothesis, means about the top to the bottom, and it is means that hypothesis is positive. In case the training example is negative, means training example is negative, means we are moved to the generalized to the specific. That is about the negative example. That is simple logic we can remember about the candidate elimination algorithm. Whereas some space is there, some gap is there in between generalization, in between the specialization as well as generalization. That space is called inversion space in candidate elimination algorithm. What it is contains, how it is represented in the training examples about the specific to the general as well as general to the specific. We discuss with some example, right? Notice that algorithm is specified in terms of the operations, such as a computing minimal generalizations and a specialization for a given hypothesis, and identify the non-minimal and non-maximal hypothesis. Means we are take maximally minimal generalization to the specialization and identify the non-minimal to the non-maximum hypothesis also. And the detailed implementation of these operations will be depend on course and the specific representation for the instances and hypothesis. Means this implementation about this generalized as well as specific hypothesis, it depends on the number of instances are there and hypotheses are there. Here number of instances is nothing but x. It is depends about the x, as well as hypothesis is about the h. That is about the hypothesis. It is depends on the number of hypotheses are there, number of instances there, and it is depends about the hypothesis. Means about the hypothesis. Means here number of instances is also defined. How it is finding. For example, take some attribute values, some values in this values. That is about the. For example, it takes some example how we can calculate some instances for the given hypothesis or given training example. For example, 4 attributes means about the sunny, means sky is there, as well as humidity is there, and water is there, and wind is there. 4 attributes are there. For example, we can take some understand purpose. How many instances are there? We try to define, means we try to some attribute values. First day is sunny, second day is sunny, third day is rainy in case. As well as here is first day is normal, second day is normal, and third day is high, for example. We can use. And first day is wind is normal, means cool, wind is cool, and second day is also cool, and third is normal, means about the strong, for example. And wind is means about here is also strong and normal. Sorry, wind is cold as well as cold and change, for example, means change. So when you compare with the instances, for example, first attribute value is there. How many instances are there for first attribute value? Means this attribute value is defined, especially means what the variation is there? 2 attributes. Why? Because here sunny as well as rainy, means only 2 attributes are there. We try to calculate how many instances are there for the given training example hypothesis. Means it is defined with the help of the how many attributes are there? Nearly 1, 2, 3. Means sky attribute is the 3 is there. We can start with 3 into 2 hypothesis. Means 6 instances are there in this example. Like that. Means we are comparing, we are analyze it. We can go to the how many instances are there. It is depends on the number of attribute values of the specific attribute. It is depends. Means if any attribute value change, we can start the another instance also. So like that we are discussing. Means like in the next one. However, the algorithm itself can be applied to any concept learning task about the C of X. Concept learning task. And hypothesis space for each means H of X. Hypothesis H of X. Means space for each these operations are well defined. And in the following example, trace the algorithm. This algorithm, we see how such operations can be implemented for the representation used in the Angel Sports example problem. Means we are discuss what is happening in actually what is the actual process, what is the main process going on in maximum in candidate elimination algorithm. How it is implemented, how it is activated. Here we take some example about the training, means about the example for the understand purpose about the candidate algorithm. That is about the here training examples. 4 training examples are there, maybe 4 instances are there, as well as some attributes are there about the sky, air temperature, humidity, wind, water forecast. This Angel Sport is nothing but a concept learning. Means about the file output. Means based on these attribute values, it is finalized. Means it says yes or no. Means about the some Boolean operation. We can say it is yes or no is represented. Means we can take about the first day. Sunny, warm, normal, strong, as well as warm and same. Means is enjoy the water sport. It is about the yes. Second day. Sunny, warm, high, strong, warm, same. Second is also enjoy the water sport. Means yes. And third day means the training, cold, high, strong, warm, change. It also means here no. Means it is not enjoy the water sport. And the fourth example means it is about the sunny, warm, high, strong, cool, change. But enjoy the water sport. Means in this given example, when I observe this example, here is nearly 3 positive examples are there. Training examples are there. That is about the 3. D value is here 3. Why? Because positive representation. Whereas come to the negative means here means value is no. So only one negative example training example is there in this given example. Means here only one negative. Means here 3 positive examples are there. Based on the means whenever it is just for the condition yes means it is positive means about the plus. As well as whenever it is discussed means about the by the means yes condition it is positive. Whereas come to that condition about the means of x is equal to negative means no means it is separated by the minus. And we can define once again it is positive. Means when compare this totally here 3 positive examples are there. 3 positive examples. As well as 1 negative example. Training example is there. So based on this given example, we discuss what is happening in candidate elimination algorithm with these positive training examples as well as negative examples. Why? Because the candidate algorithm is mainly concentrated on both positive hypothesis as well as negative hypothesis. So we discuss about this with the candidate elimination algorithm in next session. So up to now we discuss about the candidate elimination algorithm. Means how it is, what is the major play, what are the basic concepts there in training examples, means about the classification algorithms. Means about the candidate elimination algorithm. As well as the candidate elimination algorithm is also comes under the machine learning algorithm as a like in part of the concept learning. So in this candidate elimination algorithm, we are new. Means we can use some two words about the hypothesis constants as well as hypothesis inconsistency. And we can add some ocean space also. One more concept in this candidate elimination algorithm. Means if any hypothesis constants, we can keep as it is in the ocean space. If any hypothesis negative, means not consistent, means inconsistent, we can simply remove that hypothesis from the ocean space. So we can follow the same principle, means about the ocean space. Means if any hypothesis constants with the given, means if any given hypothesis consistent with the given training hypothesis, we can keep as it is in the ocean space. If any hypothesis not consistent, means inconsistent with the training example, we can simply remove that hypothesis from the ocean space. Means in this removing as well as keeping, I mean inserting hypothesis mainly depends on the consistent of the hypothesis. That is about one main parameter about the candidate elimination algorithm. Means whenever that two conditions are satisfied about the consistency as well as inconsistency about the hypothesis. If hypothesis consistent, we can keep. If hypothesis inconsistent, we can remove. So based on these conditions, we can discuss about the candidate elimination algorithm. Why? Because in this, especially based on these conditions, we define version space in between the specific hypothesis as well as general hypothesis. And then we discuss about some concept about the generalization, and we can give some examples. Whereas come to the candidate elimination algorithm, mainly if training example is positive, we are moved from the specific to the general, means top to the bottom. In case the training example is negative, so we can move to the towards the general to the specific, means bottom to the top. And then we discuss one by one in coming class with example about the candidate elimination algorithm. The same example is there. We can discuss in the next session. And then finally, in this today class, we discuss mainly candidate elimination algorithm. What is need of the candidate algorithm? How it is important to the concept learning. Means about the, whereas come to the main can overcome the disadvantage about the foundation algorithm, we are introduced the new algorithm, that is about the candidate elimination algorithm. Here are some elimination processes there. But that elimination is depends on the consistency as well as inconsistency. So whereas come to the foundation algorithm, if any negative result is there, or if any negative example is there, training example is there, we can simply ignore about that training example. We can simply eliminate that. Only it focused only positive training examples in the foundation algorithm. But we need some concentration in negative training examples also. So based on that requirement, the candidate elimination algorithm comes to the concept learning. Means the concept learning is considered both specific as well as positive example training examples as well as negative training examples. So it is in between positive and negative. Means a positive means negative means it is generalized as well as specific. Some space is generated. That space is called version space. How it is works based on some training examples we discuss in the next class. Thank you. Thank you, Nandal.
Like, share and subscribe. Hit the bell icon for more updates.